another quick plating update. I don't want to keep going on about this because this is really just a very quick hacky experiment just to see if it works, but it is working pretty well now. The figure I came up with of about 40 milliamps per square centimeter seems to be about right. I've plated a few other small things this morning. This is for the starter motor. This was a brass nut stolen off one of the parts starters, which I need for the good one I've rebuilt, which I'll show in a minute. And I thought I'd do an experiment, and this is actually the key to this little lab I'm in. These are brass, so that's another one. That's how they start off. That key's basically identical, different tooth pattern of course, but same sort of key. And I thought, well, let's see how hard wearing this nickel plating is. So I cleaned up the key for the lab, and I've had that in the plating solution for about 5 minutes. It's probably going to take some experimentation to see how long you should leave it in there, to see how much of a coating of nickel you get on it. But that is pretty well coated. I cleaned the brass up with steel wool in phosphoric acid, a very weak phosphoric acid solution, and gave it a good scrub, and then degreased it with acetone. And that was about 5 minutes in the solution. What I've found works quite well is tying a little piece of copper wire to them, and then I can dip them in the solution and hold them in place with the helping hand there and connect the wire. So the last thing I'm going to do is this, which was the little tapered piece that goes under the foot brake adjuster. I believe this is some kind of engineering bronze. I just made it from an offcut that I had. I think that came with my lathe, so I've got no idea what it actually is. It doesn't quite seem to be brass, so it happened to be there, so that's what I ended up using. So I'm going to put this one in, which I can't really do with one hand, but I'm going to leave that one in there and give that a go and see how well that one works. This is just quickly outside in natural light, just to see the difference that the plating makes. It looks fairly even. The key does still work, I checked that. I don't think that's going to be a very thick coating. I didn't leave it in there for very long, but I want to see how long it takes for that to start wearing off when it's basically rattling around on a keychain and being used to lock and unlock a door. It'll be a good test for it. The starter motor is all put back together, totally finished now. I ended up zinc plating some of the hardware, just this little bolt here. This nut was off one of the other starters. It was actually brass, but I nickel plated that. I'm just going mad nickel plating everything at the moment, mainly because I can, and what I want to see is if it actually stops things rusting. So the starter is all back together and tested. It works really well. It didn't the first time I tried it because I set it up in the vise. I didn't want to scratch it, so I had a cloth between it and the vise jaws, and then couldn't figure out why it wasn't working at first, but it was because I was using the vise as the earth terminal, so there was no earth path, so of course it wasn't going to work. But with it all back together, it's working quite nicely, which is good. I've put away the alternator stuff that's in a box with all the old starter and dynamo parts. That'll be a project for some time in the future. This one should be fine for now for the Brooklyns, and I think I've mentioned before, and other people have mentioned it, for the Brooklyns you could run off the battery for a long time, especially if you're not driving at night and you're not using headlights. Because it's a magneto driven car, the only real draw is the fuel pump and the brake light. I think that's pretty much it. What else have I done? I have brake parts that I've painted sitting in the little toaster oven. Because the paint I use is engine enamel, it actually works better if you bake it on. So I usually bake it on at sort of 90 to 100 degrees C, and it makes it quite tough. I've cleaned up a set of brake parts, so I've got a nice set of tubes I can use. These were more of the things I was just playing with the nickel plating. These are the little retainers for these spring tubes. So that's what holds them in place. I've chosen the best set of these little rod end things, and I nickel plated those as well. This was just some half-inch nuts. The reason I'm trying this is because a lot of this hardware, if we have a look, it's all new machine stuff, but it's just plain steel. So for example, nuts like this are just raw steel, and they surface rust, they flash rust. So they need some sort of coating to stop them rusting. And I'm hoping that the nickel will provide that rust protection. I nickel plated the little D-ring things. I've chosen the best set of these spring holding screws, and I've found out that the little notch in the end isn't really essential. These don't tend to come undone. When I assemble these, I'll Loctite them in place anyway, so I don't think there's any way they'll come undone. This is some of the original washers. They get a little bit worn out. You can sort of see the holes go oval. I do have other washers. They're not quite the right size. They're just a fraction smaller. But as long as they hold the spring in place, I think they should do fine. There's actually a washer at either end, so there's one down this end and another washer up here. I've just been tidying up. I pulled the English wheel out so I can have a play with that again and start looking at copying this door. There's quite a bit of shape in it, so it's probably not going to be as easy as I think it is, but I mean, it's all simple crown, but it's not even across it. And you can see how much shape, if I go down the end, how much of a barrel shape there is in these Brooklyns with doors. Not all of them have doors, but I kind of want doors on mine because otherwise they're just so hard to get in and out of. This is a test piece I did ages and ages ago, just to play with the wheel. But you can see that's got a lot of crown in it. So theoretically, I do know how to raise crown in a panel. Just trying to get it even across a shape like that is going to be interesting. As I say, I think the last thing I actually did on the wheel was the boot lid. And that does have crown in that direction and in that direction. So in theory, I know what to do. In practice, it's going to be interesting. And I think the only other thing today, this is something I picked up maybe a month or two ago from an op shop. And it's a shoe last. Cobblers, you might say. And that's true, that's what who would use this. They used it for shoemaking, I guess. The reason I've got it is because my mentor Joss was always very keen on telling me to always keep an eye out for interesting pieces of metal that you can use for metal shaping. So things like hammers, dollies, anything you can use to shape bits of metal. And he had a huge collection of different bits and pieces, lumps of steel, I think on the Austin 7, some of the shaping on that I did with an old cannonball and an old iron, which just happened to have the right sort of curved shape on the bottom of it. So Joss always used to say, keep an eye out for those things. And I distinctly remember him saying, in a way that only Joss could, one day, oh, don't you have a shoe last? As if everybody's got one. So now I do have one. I think it was $8. So that was a good little op shop find. There's quite a few op shops around here that we pop to from time to time, and I'm always getting little bits and pieces. The other day I've been looking for just a spanner to go on the lathe, and found that in an op shop for $1 or whatever it was. So it's always worth having a look. And I think for today that's it. Tonight's little job is rebuilding a SU fuel pump, which is going to be interesting because I took this apart months and months and months ago. I think that was in my old house, so over 6 months ago. So of course now I can't remember exactly how it goes back together, but I've dug out my MGB manual because it has a section on rebuilding these fuel pumps, and the rebuild kit actually comes with quite good instructions. And I've had a look at a few YouTube videos that explain how to do it. So hopefully it won't be too bad. I'm just wondering if this is a new kit, so hopefully these diaphragms are ethanol fuel friendly. I think they should be. I try to avoid the ethanol fuel anyway, but that's just getting a little bit, it's probably going to get harder and harder. But these are the old parts that came out of it. This is all the stuff you get in the rebuild kit. This here is it's like a voltage suppression diode. It's a special sort of diode that the rebuild kit comes with. The original didn't have that, but there's no harm fitting it. They're not polarized, so it'll go either way around, and that'll reduce the arcing across the points. And I think in here I've got, it's a mixed tin of SU carburetor parts and SU fuel pump parts, so that's going to make it interesting as well. But I'll give it a go and see if I can get this thing to work. Okay, I've encountered my first problem. It turns out that these pins aren't all the same sizes. And when I tried to push the pin through this pedestal I was going to use, it broke. And the pin did seem a bit tight. I wasn't sure if that was normal or not. But it turns out if you measure these, this is the new one, 0.625. This is the old one. And that's 0.058, 58 thou. So it looks like there were some that had a narrower pin. And when I actually look at the contacts as well, the holes in there are different sizes. So the new one fits the new pin. So I went through my box of old SU fuel pumps that I had, and I found a different model one. Just slightly different, but it matches the bigger pin size. So I will use this. I ended up going and getting my laptop so I could watch the YouTube film showing how to do this again. But he does skip a couple of little bits and pieces. One is he leaves out the diode. So this is it's a transition suppression diode. It's non-polarized, so it'll go either way, but what that does is it reduces the arcing on the contacts so they'll last longer. And the other thing he does is when he puts the diaphragm in, he uses the plastic spacer, whereas the kit comes with these little brass rollers. And the idea, you could sort of see them in the MG diagram, is they go around there and they keep it centralized. It doesn't really explain how you're supposed to get them in there, so I guess you just kind of have to feed them in. I think what'll work is I screw that in far enough so that I can get them in there, and then they should stay in place and allow me to screw it down to where it needs to be. It's quite a fiddly little job. The instructions that come with it have little diagrams, but they're almost unreadable. I mean, you know, it's just so small and such poor quality, you can't really see what's happening. I'm not sure this mentions the little roller. Yeah, so you set up the position of the diaphragm until the toggle just works, and then you basically screw it back to the nearest hole, so this way up, and then back 4 more holes, and that should set the position, and then you put in those little brass rollers. This is the SU fuel pump all reassembled. I haven't fitted the filter or the one-way valve or the inlet and outlet connections yet, but I wanted to bring it in so I could test power it up. I have it hooked up to my little digital supply there, set to 12 volts, and if we power this up, you can see that it does work, or rather hear that it does work. The sound of these always reminds me of World War II Vickers machine guns. It's about the same sort of firing rate, I guess. But if we connect it up and look at the supply, you can see the amps display there jumping around. And that's because, of course, it's not a constant current, because the points are switching it on and off all the time. And this is again where these digital meters can be a disadvantage, and an analog meter actually works better, because the nature of a slow analog meter like this is it effectively averages out the current. So, you know, I could see there it's drawing slightly less than an amp of current, which sounds about right. I've never actually used this kind of pump on a car before. My MGBs all had the little square facet style pumps, and my Austin 7 has actually a reasonably modern fuel pump hidden away in the boot. So this is the first time I've used one of these, but because I want the car to be period correct and an accurate replica, one of these is perfectly in period for that and correct to use. So that's the fuel pump rebuilt and done. It's the non-return valve in there rattling around. That seems to work pretty well. The starter motor is rebuilt and done, and I'm just waiting for a ring terminal. I bought new terminals so I can finish this off, and then the dynamo will be done once I get the parts I've ordered from the UK, which should be on the way soon, and that'll be a new terminal block for there and new screws for all of this, which is good. It took me a few nights to get the fuel pump done, because I had to take a break halfway through last night to go to the pub, which basically means sit there with some beer, chatting to a friend of mine who's down south. So that's okay. Some nights you don't get too much done. I just try to do a little bit all the time, just to keep things progressing. And I'm sort of procrastinating a bit as well, because I'm waiting for the engine parts to come back, and then I'll start building the engine and start trying to figure out the body, which is going to be quite a big job. Tonight, I thought I'd try tackling the rather mangled handbrake lever, straightening it out and figuring if I could reuse this one and shorten it. I took it all apart, which actually took a bit of work. It was all seized up in here. I had to soak it in penetrating fluid and then use a little bit of heat on it to get it all to come apart. But I got it apart okay. This was horribly bent before. To give you some idea, that was the rod for the handbrake release. And you can see how somebody had bent it kind of like this. I managed to straighten it up. Unfortunately, at this point there was a thing. Yep, it's not hot anymore. This was brazed onto it at that point. I'm not sure what that would have been for. It didn't seem to be in the right place to be a support for the handbrake rod, but I heated that up to get that to come off and found that the handbrake has actually been cracked. It's a bit of an odd colour, but you could actually see it had cracked there. And I'm not sure if it had cracked when they bent it and then they brazed that on just to strengthen it up, or if it cracked when I pulled it apart. I think the crack was already there. It may not have been all the way through. But that came apart, but I was able to heat this up and straighten the rest of it. So I just kind of did that in the vise and with a hammer. It's got a little bit mangled up. It's still a bit warm. It's not perfect anymore. And you can see here, it's actually been stretched a little bit. It's a bit thin there, where the metal has sort of been shrunk in, because this is where one of the bends was. But I've managed to get most of it out, and I've managed to straighten up the channel here by using just a piece of steel that I sort of shaped with a file to be the right shape to follow this channel. And then I was able to heat this up and using the vice grips hold this in the channel and then hit it with the hammer, and that helped reform the channel, which was all wavy where it had been bent, and also flatten this out. So it's fairly flat now. Probably still needs a little bit of work. This though is effectively a full-length handbrake, so this does match this one. And obviously on a car where the top of the scuttle is about here somewhere, that handbrake's not going to work, so it needs shortening. That one's in nice condition, I don't want to ruin it. So what I think I will be doing is figuring out the height I need, and then I should be able to cut this and re-weld it back together, and also redo the rod for the release on the handbrake, and that should be fine. I should be able to get a good strong weld on this, I think, if I carefully V it enough and V the notch and then build up the weld slowly. That should be fine. And this is just the handbrake, remember, it's not the foot brake or anything like that. But I'll give this a bit more of a clean up. I'll probably hit it with the wire brush. Probably needs some sort of sanding. Definitely needs degreasing, so I'll probably just leave it in the degreaser overnight. And everything around here is still very hot. And I'll put these in the degreaser as well. So I just need to figure out what the height of this will need to be. So it's going to have to be basically down here somewhere, so it is going to be quite a bit shorter. Hopefully there's still enough leverage on it, which I won't know until I've actually got the brakes set up, I guess. Looks like she's converted her car to electric.